Okay, so today's video is on lesson 4.4. It's the second part. We are going to be doing more complex radical equations. So let's get to it. The good news is that we have the same three steps that we talked about the other day. What you want to do is step number one, you want to isolate the radical on one side. So if you have anything added or subtracted or multiplied or divided to the radical, then you need to get rid of it. So once you get it isolated, then you can square both sides or cube both sides depending on what your radical is. And then once you get rid of it, you have to look at it and then you have to solve it according to what kind of equation you have left. The reason why yesterday was so easy was you wound up with linear equations. Today, we're going to wind up with quadratic equations. All right, so we're going to take our highlighter. You just need the one for today. We're going to talk about something called extraneous solutions. And I mentioned it in the last lesson. Extraneous solution is when you solve an equation and you wind up with a fake solution. It's like an imposter. So a lot of times when you have a quadratic equation, you're going to get two results, but one of them is fake. And we call that an extraneous solution. And the only way that you can figure out if it's extraneous or not is you have to check your answers. And I'm going to show you how to do that in a second. But that's a very, very special vocabulary word. It will show up on your quiz. It will show up on your test, your benchmark, your end of course, all of these things. So it's really important you know what extraneous means. Okay, so yesterday we learned how to highlight the radicand. So I'm going to look at this equation. I'm going to highlight everything under the square root. Now, there is absolutely nothing on the side of the square root. So if you draw your line right down through the middle of your equal sign, you got the square root on the right, and then you got x plus 1 on the left. So what that means is that you're ready for step 2. So step 2 is we're going to square both sides. The whole point of us squaring both sides is that a square will cancel out a square root. So it's actually pretty basic. So if I square the square root, I wind up with the radicand, which is 7x plus 15, okay? But here's where mistake number 1 happens. So in the last lesson, I showed you how, or I reminded you how to square a binomial. So a lot of people want to put x squared plus 1. This is not true. Because when you actually square a binomial, we're going to go ahead and do it right now in our notes. So draw a box. And you're going to square x plus 1. So you're going to multiply x plus 1 times x plus 1. You're going to wind up with 4 terms, and the diagonal will add together. So we wind up with x squared, 1x, and 1. If you combine the middle 2 terms right here, you wind up with x squared plus 2x plus 1. See? So there's a lot of stuff going on between this first line right here and then that next line. So you're gonna have to kind of go off to the side and you have to square it and then come back and write down the result. I'd hate for you to do that incorrectly and then everything else down the line is going to be wrong, okay? So now that you have that simplified, here's where some people get stuck again. They get to this point and they're like, well, what do? I don't know what to do. So it's either going to be linear or it's going to be quadratic. This particular one is quadratic because it has an x squared in it. So if you have a squared x, it's quadratic. Quadratic equations are harder to solve than linear. Yesterday, we had linear equations. All you have to do is get x by itself and you're done. But if it's quadratic, what you have to do is you have to make it equal to 0. Then you have to factor it, which they did. So they found the factors of negative 14 that added up to be negative 5. And they found that to be negative 7 and positive 2. You see their factors right here. After you factor it, because y'all know that factors are not solutions, you have to set each factor equal to 0. And then you have to solve for x. And then you're like, man, that's a lot of work. So much work. But you know what? You're still not done. You're still not done because there is an extraneous solution hanging out here. And you got to figure out which one is good and which one is fake. So what you're going to do is you're going to check it. Okay, so here's what we're going to do. We're going to check it Now, every year I assume everybody knows how to check, and then every year I have a bunch of people say, I don't know how to check. So let me show you what to do. So on your notes, I know it's already written out, but I want you to write a couple of things down for me. Right here, we're going to check x equals 7. And then over here, we're going to check x is equal to -2. Okay, so what you have to do is you have to look at the original problem. So where's the original problem? It's right here. Okay, it's x plus 1. We're going to write it down. I'm going to write x plus 1 equals the square root of 7x plus 15. It's really important that you start with the original form, because if you do anything to it, your check is invalid. You got to make sure you start with the original equation. Very important to know. So what we do to check is we're going to highlight whatever we think the solution is. So I think the solution is 7. Wherever there is an x, you're going to replace that with 7. So as you can see underneath it, that x became 7 here. This x on the left became 7. So you're probably going to have to substitute more than one time. And here's the key. What you want to do is you want to make sure that the left side equals the right side. In the past, when I've been teaching this before, a lot of people think that checking is just solving. It's not solving. All you're doing is making sure that the left equals the right. That's it. You can do this part in your head. You can do this in your calculator. It just depends on what you want to do. You can just do 7 plus 1 makes 8, right? And then you can type this in your calculator. You wind up with the square root of 64, which is also 8. Does the left equal to the right? Yes. 8 is equal to 8. So that checks out. It means that x is equal to 7. That means it's an actual solution. It's not fake. So chances are the other one's probably going to be fake, but we're going to make sure. So I'm going to plug in the -2. Now notice this -2 has now been replaced for where the x was. Same equation, just a new number. So you start over. So all you have to do now is you have to make sure that the left side, now the left side is equal to -1, matches the right side. The right side, on the other hand, is +1. -1 does not equal +1. So what that does is it gives you a fake result, meaning that this is not a solution. It was fake. If you graphed it, it would not be on the graph. It would not exist. So we call that extraneous. That is an extraneous solution. And that happens when you have a limited domain. A square root has a limited domain. And if you square a variable, squaring the variable is key. It's always a good idea just to, in general, check your work all the time. But you absolutely have to check your work if you ever square a variable. So I have one example. The reason why I have the one example is because these take so long to work out. You only really need the one, plus you have the one written above it. So here's what we're going to do first. We're going to highlight the radicand, and we're going to make sure that we're ready for step 2. So I don't have anything added, I don't have anything subtracted to it. So I'm ready for step 2. Step 2 is square both sides. When you square both sides, do not square individual parts. You're not allowed to do that. You've got to square the whole side. So parentheses is very, very important. When you do that, you wind up with this, just the radicand, which is 2x plus 7. But over here, y'all, if you're not paying attention, that's going to cause you to miss that problem. It is not x squared minus 16. You have to multiply it out. So x minus 4 times x minus 4. So just go over to the side, do a little bit of work, simplify it, because you know you can add the -4x's. So when you square x minus 4, you wind up with x squared minus 8x plus 16. So you're going to come back over to your equation. You're going to put the simplified form. And then some people get stuck right here. They're like, oh, I don't know what to do. Well, it's because it's quadratic. So if it's quadratic, it's going to have a little x squared here. So I'm going to put quadratic. If it's quadratic, what you want to do is you want to make it equal to 0. The reason why you make it equal to 0 is because you have to factor to solve. And it should be a pretty easy factoring problem. So what would be the easiest way for me to make it equal to 0? I think if I just subtract 2x and subtract 7, that will work. I'm going to give you a little hint. I've watched classes all day work on their homework. And that first homework problem, they're adding incorrectly here. So make sure you're using your calculator to just kind of double check your work. Because at this point, what happens is that you have to factor it. And they're getting stuck because they added it incorrectly and they couldn't find factors that worked. So if you can't find factors that work, it's probably an indication that you've done something wrong. So just go back and check it. So what will work here? I think -1 and -9 will work. Remember, this is a one and done, so you don't have to do anything fancy. So we're just going to put our factors x minus 1 and x minus 9. Now we know factors aren't solutions. So what we have to do is set each factor equal to 0 to solve it. So add 1 to both sides, you get x equals 1. Now I think this is a solution, I'm not sure. And then you add 9 to both sides here, you get 9. If at any point that you squared a variable, you might have an extraneous solution. And you know what? We squared that x right there. So we absolutely have to check to see if it's fake. And I know it's really frustrating and it's a lot of extra work, but it's just part of the problem, okay? So we're going to check x equals 1 first, and then I'm going to check x equals 9. You have to do both of them separately. Step number 1, write down your original problem. Step 2, take this number that you think is a solution and substitute it wherever there's an x. I'm going to have 2 times 1 plus 7, and then 1 minus 4. So I substituted a 1 for an x. All you have to do now is use your brain or your calculator, figure out what is the square root of 9. That is 3. 1 minus 4 is -3. Then you have to make a decision. Is the left equal to the right? It's not. So there's your fake solution. So I think that x equals 1, I think that's my extraneous solution. So I'm going to go back over here, and I'm going to mark it out, and I'm going to write extraneous underneath it. I still need to check the 9 because it's absolutely possible that neither will work, but you're going to do the same thing, okay? So you're going to write it down. Wherever there is an x, you're going to replace a 9. Okay. And then all you have to do is just use your calculator, or you can just use your brain. That's going to wind up being the square root of 25, which is 5. And 9 minus 4 is also 5. See, it works because the left is equal to the right. So I can go back over here and verify. My final answer is just going to be the 9. So if you don't check your work and you put in, like, you don't have homework in Delta Math, but if you did, if you tried to input a +1 and a +9, it's going to count it wrong. So you got to be really careful with it. So let's talk about the EOC for a second. Every single year for like the last 10 years, I have seen this type of question pop up, and I have seen honor students miss this problem because they're not getting the point. So let me tell you how to kind of interpret, okay? So let's say that you have this equation and we just so happen to solve that because it's the same equation that you had on page 1, okay? It's going to say, what is an extraneous solution? You have to understand that extraneous is a solution that you got from solving it. Now, earlier, if you look at your notes, here, I'll remind you right here. In your notes, if you solve that, you wind up with either a 1 or a 9. What the test people do, and it's kind of mean because they're trying to trick you. I'm being honest, okay? What they're trying to do is they're going to have you check 9. Now, we all know if 9 works because we just checked it, right? So this is an actual solution. It is not extraneous. So this is not going to answer the question, okay? Here's what the students will do wrong. They'll take this number right here, which is, I'm serious, it's random. It's a random number that they just throw in the test. And then you check it. If you plug in a -7, it's not going to work. So everybody thinks that that's going to be an extraneous solution, but it's not extraneous. The reason why it's not extraneous is because it wasn't part of the original equation. An extraneous solution only comes from solving the equation. So they might not tell you to solve it. You're going to have to solve it. So whether or not it's extraneous or not, you have to solve this equation. And I know the answer is either going to be 9 or 1. So these aren't even a possibility. No, they're not going to check, but they don't check because they're not a solution. It's not because they're extraneous. An extraneous solution is this one. It resulted from you solving it. So if that pops up on your quiz Monday or your benchmark, now you know what to do. So you have to solve it. You don't just get to plug it in. You have to solve it, and then you got to plug it in and figure out which one's which. Okay, next question. Let's say you've got 2 square roots. Looks like they're both isolated. So here's your good news. We're going to square both sides. And I'm not really squaring anything other than a square root. So if you square a square root, they cancel out. You get 2x plus 5. And you get x plus 7. Even better news, that's linear. It's not quadratic. So if it's linear, all you have to do is get x by itself. So I'm just going to solve for x. I don't have to factor. I don't have to get anything equal to 0. So I'm just going to do a few steps here. And we're done. I'm also not having to check it because if it's, I'm not really squaring anything. I am squaring. I'm squaring square root. If I'm not squaring a variable, I don't have to check it. If it makes you feel better, go ahead and check it. It will check. It will work. Okay. This one is a little bit harder. They're both isolated. You're still going to square both sides. The square roots are going to cancel out. It's going to be a little bit more difficult because it is quadratic. And for you to be able to solve a quadratic, you have to make it equal to 0. But you have to be smart about it because when I want to make it equal to 0, I want the quadratic term to be positive. So I'm actually going to subtract x squared. So I'm going to subtract the smaller of the two. So I'm going to subtract x squared here. I'm going to subtract 7x. And I'm going to add 1. So all of these are going to cancel out. Okay, write the left side in standard form. So I have x squared minus 7x plus 6 equals 0. Okay, now that it's equal to 0, you're able to factor it. Factors of 6 that add up to be -7 would be -1 and -6. Factors aren't solutions, so you have to do one more step. Add 1 to both sides. Add 6 to both sides. And when you check them, they both work out. You're not going to get anything extraneous because you didn't square a variable. You only squared the square roots. Okay, so this part looks really intimidating, but before break, we talked about what a power of 1/2 is. So a power of 1/2 is just the square root. So if you don't like the way that that looks, you can write it this way and solve it like normal. So you can just rewrite it, square root of 2x plus 2 equals 10. And you can just treat it like normal. You still have to do all the same steps. You don't have to write any of this down. You'll still have to square it. You still have to get x by itself. So I don't want you to be intimidated by a power 1/2. It's just a square root, and y'all know how to deal with those. In case you see a power 1/2, you can leave it like that. They're just raising it to the reciprocal power. So the reciprocal of 1/2 would be squared. And that's why you square a square root, because they're reciprocals. They're inverses of each other. So this is one that's linear, and that's one that's quadratic if you need a few more examples of what a quadratic problem looks like. But that's pretty much it. Okay, so if you're in the honors classes, we actually learned how to solve radical inequalities. It's actually pretty easy. You just kind of take it and you start out like normal. So let me copy this down, and we're going to solve it as if it didn't have an inequality. Now remember, there is a rule. If you multiply or divide by a negative number, it will flip this. This is positive, so I don't have to worry about it. So now that I have my radical isolated, I am ready for step 2. Square both sides. So that leaves me x minus 1 equals 16. Oh, that should not be equal, sorry. Less than or equal to. So I've got x is less than or equal to 17. So that's only one part. So the second part is what we have to do is consider the radicand. In any square root equation, your radicand has to be positive. So the radicand in this case is x minus 1. So for it to be either 0 or positive, it's going to be greater than or equal to 0. Which is also how you find your domain. So this one's really easy. You just add 1, and this is the second part. To finish your answer, what you want to do is you want to combine both of your answers, and the easiest way to see this is on a number line. So that's 1, that's 17. Their first one is everything less than 17, and the second one is everything greater than 1. And you notice that when they both match, it's everything in between the 1 and the 17. And you're going to want to fill in your circles because it's equal to. So final answer is going to be 1 less than or equal to x less than or equal to 17. If you do have access to Desmos, you can go ahead and type it in, and it's going to have a more like a 2-dimensional instead of a 1-dimensional, but it'll be everything between 1 and 17. So same answer.